Okay, so this is the chapter 1 practice test. I'm going over the whole thing. I'll try to explain every single problem as best I can. This is for once you've already tried the practice test on your own to see if you got it right. Hopefully I can clarify some things if they don't make sense yet. And then remember that I'm after school today, Thursday, August 27th. So you can come and ask questions afterwards if you run out of time during class. So on the first problem, it's a midpoint problem. For the midpoint problems and the distance problems and those types, drawing it out is going to help you to understand what's going on, help you to visualize it. So if it says that M is the midpoint of FG, that means we have F here and G on there. The midpoint means these are the same. Then it says FM is 3x minus 4. I'm going to put that on the left side. 3x minus 4. It says mg is 5x minus 26. So mg is the right side. 5x minus 26. Now when I look at it, I can see that these are supposed to be equal to each other, so I know how to write the equation. 5x minus 26 equals 3x minus 4. Then I'm using algebra to solve it, so do the opposite, be fair. So if I move 3x over here, 5x minus 3x gives me 2x on the left. If I add 26 to move it out of the left side, I'm going to add it over here, and I'm going to get 22. After that, I want x by itself, divide both sides by 2, and I got x was 11. But the question did not ask me for x. So then I have to plug it back in to find one side, and I'm going to go, okay, 3 times 11 would be 33. So 3 times 11 minus 4, 33 minus 4, and then 33 minus 4 gives me 29. But 29 is still only this side on the left. The right side, I don't need to substitute it back in because I know it's the same. So if the left side's 29, the right side's also 29. The question was asking for both of these together, so just add 29 plus 29. You're going to end up getting 58. And then this would be your answer. Make sure you're showing your work. Next problem, it's asking for a midpoint. Sorry, it's giving you a midpoint. And so we're going to still set up our drawing the same way pretty much. It says M is the midpoint of FG. And 8a plus 1 over here on the left. And FG is 42. So now it's saying all the way across is 42. Remember, we're not going to use all the way across. We're going to use the other side. So if it's 42 and that's a midpoint, cut 42 in half, this side has to be 21. And now you can make your equation where these are equal to each other. So it's going to be 8a plus 1 equals 21. Subtract 1 from both sides, you get 8a equals 20. And then divide both sides by 8. So 20 divided by 8, let me use a calculator for this one. I got 2.5. You could also put 5 over 2. If you reduce this, that's okay. So you can give me 5 over 2, you can give me 2 and 1/2 or 2.5. They're all fine. Number 3, Elizabeth and Amber want to meet for lunch. Our lives in Brawley, one lives in Brawley and one lives in Calexico. If they want to meet near the midpoint of their homes, where should they meet? So this is just so you have a visual understanding of kind of what midpoint means. It's halfway, so you wouldn't say Yuma because Yuma's not in between the two of them. If you had a line between Calexico on a map and Brawley on a map, Yuma's out of the way. But something like El Centro, that would be the midpoint. Or perhaps if you said the Imperial Valley Mall or Heber possibly, that's still kind of along the way. So the distance between A and B and this one over here that's asking about the midpoint between A and B, you're using this graph right here. So since we're going to use this graph, we're going to want to find the coordinates before we actually solve it, either one of those. So if I get this coordinate, I go, okay, I go 1, 2, 3 to the left, 1, 2, 3, 4 up. So A is going to be -3 because it went left, and it's going to be +4 because it went up. For B, the coordinate is 1, 2, 3 to the right, and 2 down. So for B, you'd go +3, but since it went down, it'd be -2. Now that we have these coordinates, the distance is easiest to do with the Pythagorean theorem. So remember that a squared plus b squared equals c squared. A is going to be the distance between the x values. So between a -3 and a +3 going this way, that would be 6 spaces. And then b would be the difference between the y values. So from a +4 down to the -2, that's also 6 spaces. And then you work it out. 6 squared is 36. 36 again. Add those together. You have to square root it. And then for the square root of 72, because this one says an exact answer, you have to actually dig back into when you were simplifying square roots. So if you remember doing a factor tree is a common way to do it. You'd go 72, I can break that up to be 9 times 8. 9 can be broken down 3 times 3. 8 can be broken down to 2 times 4. And then 4 goes one more time, 2 times 2. And then when you did this a long, long time ago, you got pairs. And then you'd multiply those together. So it'd be a 3 and 2 is going to be 6. And then the lonely 2 that didn't have a partner, it didn't have a pair, that one's going to stay inside the radical. So you'd go like this. So it's asking for an exact answer. That's the exact answer. If you put it into the calculator, you're going to lose half your credit because it's the right work, but it's the wrong format. On number 5, it says, where is the midpoint between A and B? For the midpoint, that was the one where you did those two fractions and you put them in coordinate form to begin with. So remember that you're averaging numbers, so that's why you're dividing by 2 and adding those together. So the -3 and the +3, the two x values, are going to fill out one side, and then the 4 and the -2 is going to fill out the other side. -3 plus 3 is 0. 4 plus -2 is 2. And then 0 divided by 2 is 0, and 2 divided by 2 is 1. So your final answer, written in coordinate form, needs to be 0, 1. Next one, this is not giving you a lot of direction, but because it says CD right here, it's saying the distance between C and D. So it's kind of like problem number 4. We're going to go back to the Pythagorean theorem. So the distance between -7 and -11 is 4 spaces. And the distance between 10 and 25 is 15 spaces. So this is 16 and 225. Add that together, you get 241. And then you need to square root it to get rid of the squared. So you square root 241. So you can square root the c squared. And this one's asking for 10th place, so if you put it into your calculator, it ends up being 15.5. Number 7, it's asking for the midpoint again. So here's the coordinates on this one. Remember that the midpoint is where you have an x and a y value because you're looking for a point. So set up those fractions again. X and x, 14 and -6. Y and y, 20 and 9. So 14 minus 6 is going to be 8. And 20 plus 9 is 29. 8 divided by 4 ends up being 2. And 29 divided by 2, you can leave it like that because you can't simplify it. Or you can give me the decimal version or the the mixed fraction. So it'd be 14.5. For number 8, you're trying to find all the names that you could call this angle. So because it's a single angle on this vertex, we can call it by the short name of just angle C. Where the vertex is, that can be the name. We're not going to use lowercase because all these points are capitalized. Points are traditionally capitalized. So not that one. B, C, D. If I go from this point to this point to that point, you'll see that it traces over the angle. C is the vertex. That's a good one. Next one, C, A, D. When I trace that, I started at C, I went to A, and then came down. The vertex is not here. so it's not this one. Then E is DCA, so D to C to A, that's tracing that angle. C is the vertex, that's a good one. And then this one, be careful because it doesn't even have that little angle symbol in front, so that can't be the name of an angle. G, we have ACD, so now we're gonna actually check the angle. That vertex is right where it should be. Next one, DCB, DCB, that also works. That's okay. And then angle A, this is not the vertex, so it's not this one. So you have 1, 2, 3, 4, 5. So that'd be 5 separate points. Number 9, it says draw a picture of skew lines AB versus parallel lines CD. There's a bunch of drawings that will work. So if you did a different drawing that still follows what it needs to, you still could be okay. But here's one example. So if I'm trying to draw skew lines A and B, what I'm going to do is extend out this one so I can call it A. And by using the lowercase and not putting it next to a point, it's kind of like giving a nickname to this line. So the nickname for this line is now A with a lowercase a. If I want a skew line, remember it's not supposed to actually touch the line. So I want it to go either in front or in back or to the side. So I'm going to choose this one that comes back this way. And that's definitely not parallel, but it's never going to hit A. So I'm going to go ahead and label this one as B, the line that is skew to A. And then the part that's talking about parallel C and D, those go the same direction. So I can just grab a hold of, let me use a different colored pen. Let's go with this one. Okay, so I can get this line that goes in front right here. And if I call that one C, then I can get any other horizontal line and call it D. So I'm gonna go with the one that's behind it. I'm gonna come over here, extend this out, and then that's D. So these would be parallel, the two that I did in purple. And then the skew ones are the ones that are going completely different directions, but they're still not gonna intersect. Last one on the front, it says DB is bisecting angle ADC. So that means that this ray is splitting this angle into 2 equal parts. Then it says ADB is 5x, ADB is the left side. So I'm gonna put it right here, 5x. And then ADC is 80 degrees. ADC is all of it, so I'm not gonna use 80. I'm gonna get 80 and I'm gonna cut it in half. I'm only gonna use 40, because now I can make these equal to each other. So if I'm looking for x, make these equal to each other. 5x equals 40, divide both sides by 5, x is 8. When I'm looking for the measure of angle BDC, I found that earlier when I cut that 80 in half. So there's my other answer. On the back side, it says 2 complementary angles. Remember, complementary means 90 degrees. Measure 7x plus 17 and 3x minus 20. So I add them up and equal 90. So 7x plus 17 and 3x minus 20 together should give me 90. Then I need to work it out by doing the opposite, being fair, and I also have to combine like terms. 7x and 3x gives me 10x. 17 minus 20, negative 3. That's still equal to 90. Now I need to add 3 to move it over. So I have 10x equals 93. Divide both sides by 10. And I find out my x is 9.3, but the question's not asking for x, it's asking for each measure. So you want to have both of those measures. That means you need to substitute this 9.3 into that x and find out what you get, and also substitute it into this x and find out what you get. So if I work out this first one, I would go 7 times 9.3 plus 17. So 7 times 9.3 I need a calculator for that. Jeez. 7 times 9.3 is 65.1. And then if I add 17 to it, I get 82.1. So there's one of my answers. Since I substituted that in, and the other angle is supposed to be complementary, now I can just get this and go 90 minus that. to get my other angle. So my other angle is 7.9. So 82.1 degrees and 7.9 degrees are the two complementary angles. Next one over here, number 12, it says one of these statements true, always, sometimes, or never. So there's three different options, not just true or false. Be careful. So acute angles measure 90 degrees. Remember, the definition of acute means less than 90, not exactly. So this would be never. Supplementary angles add up to 180. That's the definition of supplementary, so that's always. Complementary angles are adjacent angles. Remember that there could be complementary angles that are not adjacent, where there's two angles that are separate, but they still add up to 90. So sometimes. Because sometimes it is, sometimes it isn't. And then linear pairs are adjacent angles. Yes, because supplementary angles was 180 degrees, and so is linear pair. But linear pair was supplementary and adjacent at the same time. So we're going to go back to always. Number 13, 14, 15, 16, 17, it's talking about this drawing that's over here. So angle EBD has that little arc, and so does this one. So DBC is congruent. It has the same marks. It says name a linear pair. Linear pair are the two angles next to each other making a straight line. So if you want to, you can go with those two on the bottom, and that would be linear pair. You can go with these two, and that would be linear pair. And if you ignore this ray that's going from B to D, and you just look at the angle on the left, FBE, and then the angle on the right, EBC, that would also be supplementary. So any of those will work out. I'm going to use this one because it's pretty obvious. Like, I see it easily. I'm going to go angle EBF. And this one down here, which is going to be angle FBA. Number 15 says name two acute vertical angles. So that one's vertical to this one, but it's not acute. So I want to come over here and use this angle. And then if I put these back together, that would be the angle that would be a vertical angle to that single angle. So this side is going to be angle FBA. And then over here, sticking these two together is going to be EBC. Then number 16, it says angle ABF is supplementary to what? So ABF, we're over here. And then supplementary to, it'd be the linear pairs. So you can choose this one down here or the one that's up there. So if I go with this one down here, I'd say it's supplementary to angle ABC. And then number 17 is asking if these rays are perpendicular to each other. Remember the upside down capital T looking thing is perpendicular. There's no 90-degree angles here, so it's definitely no. Then this part is going to be where you find out, are they supposed to be equal or are they supposed to add up to equal 180? So like right here, if I'm looking for X, and if I just ignore what's there for Y, and well, that's linear pair. Those should be equal to 180 when you add them up. So you go 2x plus 40 equals 180. Then you subtract 40, you get 2x equals 140. Divide by 2, you get x equals 70. There's your first answer. When it comes to y, that is vertical angles with the 40. And vertical angles are exactly the same thing. So I don't have to do anything. I just have to recognize it's 40. For number 19, I can get the vertical angle out of the way. 82 and x are vertical angles. They have to be the same. I can just write that same number down. Over here for y, if I'm ignoring y, x and z, those two angles are supplementary. So I'm going to go y and 82 is supposed to make 180. If I subtract 82, I get y equals 98. And if this side is 98 over here, z has to be the exact same thing, so it's also 98. Number 20, you have to start with the vertical angles here because you can't solve with two variables. So if I try to do linear pair, there's an x and a y, there's no way to do that. You have to start with these two. And vertical angles are supposed to be equal, so you're going to write an equation that goes 3x minus 15 equals 2x plus 10. Subtract x, you get x on the left, add 15, you get 25 on the right. so we know what x is. And then for y, we're going to have to substitute this back into either side, doesn't matter, and then subtract from 180. So if I get 25, put it in here, it's going to be 50 plus 10. So I know that this angle is 60 degrees. If this is 60, to find y, I can go y plus 60 is supposed to be 180 because they're linear pair, they're supplementary. Subtract 60 from both sides, you get y is 120. And then over here, you're supposed to be checking to see if either one of these made a mistake or if they both did it right. So if you look at Ms. Higgins' work, 8 minus 1 is 7, and then 7 squared is this 49 here. 9 minus 3 is 6, and 6 squared is the 36 right there. If you add 49 and 36, you're going to end up getting 85. And then if you put it into your calculator, the square root of 85 does work out to give you 9.2. So this one is good. Then we come here to Mr. Patel's work and we check his work. 1 minus 8 is negative 7, which he has right here. And 3 minus 9 is negative 6, which he put right there. When you square it, negative 7 squared is going to give you a positive 49. And negative 6 squared is going to give you a positive 36. And that 49 and 36 is still going to give you the square root of 85. Since you can't simplify this, that's actually a good answer, so this one's also correct. So that means on this example, you would put both are correct. But notice I had to do a little bit more work because Ms. Higgins didn't really show where she combined those two, where she added them together, and Mr. Patel didn't show where he squared the negative 7 and the negative 6. So by showing this work, it shows that you actually analyzed it.